Hello geometry students, this is Ms. Mochisuki and I am here to talk about cones today. The first thing we're going to learn about is calculating the surface area of certain types of cones, namely right cones. It's a right cone if its height is perpendicular to the base right at the center of the bottom circle. We're doing surface area for cones and for spheres because they involve a little bit different approaches than some of the other shapes. It is no longer required for us to teach you the surface area of, for example, a prism or even a cylinder, and mostly because you can just find all the different faces area and add them together. So you won't really need to have a lot of instruction on that. If you ever really need to do it, just find each surface separately and add them up. But for a cone, it's a little bit more complicated. So we have a special formula we're going to come up with. Remember, a cone, circular on the bottom, has a circular base and a vertex not in the same plane as the base, and the altitude goes from the vertex down to the base. Okay? It's the perpendicular distance between the vertex and the base. So in the right cone, as I mentioned before, the height is going to hit the base right at its center point. So you can see the red height over here. It looks like it hits right in the center. There's another piece of information that we're going to need to use, and it's called the slant height. The slant height is the distance between the vertex and a point on the base edge. So actually going down to the circle itself, you can see where we have it labeled on the figure. Okay, so the slant height itself is the distance between the vertex and a point on the base edge. So we're going to start off by trying to find the lateral surface area of a cone. If you were to lay a cone flat by cutting down its slant height and then opening it, separating it from its base, you would get a picture which is called a net that is shown at the right. You can see the circular base on the left that has the radius of the base as r, and the partial circle over on the right is what results when you lay flat the lateral part of the of the cone, sorry. And you can see here that that is a part of a circle. It's a sector, and its radius is actually the slant height of the cone. Now we know what the area of the base is. It would just be 2 pi r. But remember that that lateral surface, when put back together to make the cone, the arc length would be 2 pi r as marked in the figure. So we know that the base area of the small circle, that is the base, okay, is just going to be something simple. That's just pi r squared. But we have to figure out the lateral surface area. And since it's a sector, we're going to treat it like we do sectors. We know that if we can figure out what fraction of the whole circle that particular sector is, we'll be able to figure out what the area of that sector is. We know that it will be a part of the circle. So on the left-hand side of this equation, we set up a proportion. The area of the sector over the area of the circle is going to be equal to the arc length over the circumference of the circle. Usually we're dealing with degrees, but here we don't know the degrees. We instead know the arc length. But the arc length is going to be the same fraction of the circumference as an angle would be of 360. So we can use that instead. So the area of our sector divided by the area of the circumference of the circle. Now if you take a look at the circle we have here, it now has on the right, on the lateral area, it now has a radius of L. So its area of the big circle would be pi L squared. And that's going to be equal to the arc length of the sector, which remember is 2 pi r, divided by the entire circumference of that circle that the lateral surface area is a sector of. So that would be 2 pi r over 2 pi L. That would be the circumference of the large circle that contains the lateral area. So if you multiply both sides of that equation by pi L squared, you get that the area of a sector is equal to pi L squared times 2 pi r over 2 pi L. And if you look at the equations, the 2's will cancel. One of the pi's in the numerator cancels, and one of the L's cancels. So what's left behind? Pi RL. So the area just of that sector is pi times r times L. So it's pi times the radius times the slant height. Which means that if we're going to try to find the total surface area of a right cone, and this only works for the right cones, folks, the surface area is going to be the base area, which is pi r squared, plus pi RL, which is the lateral surface area. R is the radius of the base, and L is the slant height. Here's the height. What you want to make sure you remember is that you will need in many problems which are doing this. If it is a right cone, then you know that the radius squared plus the height squared is going to equal the slant height squared. Very often they won't give you exactly the radius and the slant height. You'll need to figure out that slant height. Or you'll need to figure out the radius. They can ask you different things. So basically, just remember to use the Pythagorean theorem as you have a right angle in a right cone. So let's find the surface area of each right cone. So we'll do A first. Let's do A together. Well, you can see that it's clearly marked. It has a radius of 3 centimeters, a height of 4 centimeters, and a slant height of 5 centimeters. So we can go ahead and figure it out straight from the formula where the total surface area is pi r squared plus pi RL because they gave us all the information we need. So let's just substitute it in. The total area is pi times r squared, which is 9. So 9 pi plus 3 times 3 is the radius times the slant height, 5 times pi. So simplifying it, we get that's 9 pi plus 15 pi. For a final answer of 24 pi square centimeters. This is an exact answer. If we asked you to do it to the nearest tenth, you would need to get out your calculator. And don't forget that the units are centimeters, and this is area, so your units are going to be centimeters squared. So I'm going to give you some time now to find the one on the right. See if you can figure out the total surface area. It's a little trickier. Okay, let's take a look. Well, we know that the radius is 5 inches, right? But what's the slant height? It's not there, is it? So we need to figure that out. Well, we can look at the right triangle made up of the radius, the height, and the slant height and use the Pythagorean theorem to figure that out. Here we go. Since the radius is 5 squared is 25, and since the height is 12 squared is 144, so that will equal L squared. So 169 equals L squared, so the slant height is 13. Now we can move to our formula to figure out the area. The total area is going to be the base area, which is just 25 pi because it's 5 squared times pi. And the lateral area is the radius, 5 times the slant height, 13 times pi. This simplifies to be 25 pi plus 65 pi. Add them together, and you get a total of 90 pi square inches. Don't forget your units. And this, again, is an exact answer. Now we're going to move on to volume. Now that we've finished the surface area, we're going to look at these cones. Consider a cone that has a regular polygon inscribed in the base. The pyramid with the same vertex as the cone has a volume, we know, of 1/3 base area times height. Okay, if you look at the different polygons that are being drawn inside, the first one is a pentagon, but the second one has a lot of sides, so it's even hard to tell what type it is. And as you increase the number of sides of the polygon, they are approaching the being an actual circle, which is what we have on a cone. So when you think about it, the volume is going to approach 1/3 pi r squared h as the base area approaches pi r squared. So essentially it really is the same formula. It's the volume is equal to the base area times height, but the base area is just the area of that base, which is a circle, so pi r squared. Unlike pyramids, that will always be the base for a cone, so it makes it so that you have a formula that you can always use and it will be the same formula all the time. Okay, it'll be 1/3 pi r squared h. So the volume of our cone is going to be 1/3 pi r squared h, where you can say it's the same as 1/3 base area times height. And it's okay to have the cone not be a right cone in this situation because of Cavalieri's principle. So there's our formula. Now we have a couple of problems to try. So we are going to look at A. In A, we have the radius and the height. So let's figure out what the volume would be. Well, we know that the volume is going to be 1/3 the base area, which is 100, times the height, which is 8.4 times pi. So we've got 100 pi times 8.4, and then we're going to multiply it by the 1/3. And when we simplify that, we get 280 times pi meters cubed. Actually turns out to be kind of simple. I think finding volumes of cones is easier than finding surface areas. So let's take a look at this next one. Take a look at it, figure out what your radius is, and then go ahead and try to do it. Okay, let's take a look at it. Since the arrow is pointing to the diameter, you have to cut 6 feet in half because your radius will only be 3 feet. So now we have everything we need. We just need 1/3 times pi r squared h. So here we go. 1/3, the r squared, the 3 squared is 9, times the pi, times the height of 2. And what do we end up with? 6 pi cubic feet. That's it. So let's move on to the next problem. Here we have a right cone that has a radius of 5 feet and a slant height of 13 feet. We want you to find the volume. Well, think about the volume formula. It's 1/3 pi r squared h. We don't know we know the radius. Okay, and we know the slant height, but we don't know the actual height, so we have to figure that out first. So let's do that. R squared is 25. The height squared we don't know, but that will be equal to the slant height squared, which is 169. So subtracting 25 from 169, we get that our height squared will be 144, which means our height is 12. Now that you have both the radius and the height, take a few seconds, figure out the volume. Okay, the volume is going to be the 1/3, the radius squared is 5, then we have our pi, and then we have our height of 12. Multiply it all together, and you should get 100 pi cubic feet. I hope you all were able to get that. Let's move on. This time we have a cone with volume 8 pi, and it has a height of 6 units. So when trying to find the radius, we have to say, oh gee, what we know is 8 pi, that's the volume. And the volume is equal to 1/3 the radius, which is x, so 1/3 x squared, times pi, times the height, 6. So what we need to do with this equation is solve it for x, the radius. So 1/3 of 6 is 2 pi x squared then. Okay, divide both sides by 2 pi, and you get that x squared equals 4. So x is 2. 2 units is the length of this radius. Okay, now we're going to be working with similar cones. When you have two cones that have equal ratios of their linear measures, such as heights or radii, they are called similar cones. So if two similar solids have a scale factor of k, then the ratio of their volumes is equal to k cubed. This is true about any similar solids, not just the cone. We've been doing it already for others. So cone A and cone B are similar. The height of cone A is 6 inches and the height of cone B is 2 inches. Given the volume of cone B is 18 pi cubic inches, find the volume of cone A. Well, we're going to start by first figuring out the scale factor. The little red one, which is cone B, has a 2-inch height, and the blue one, which is cone A, has a 6-inch height. So our scale factor is going to be 2 to 6, which is 1 to 3. Could you have done it upside down? Yes, as long as you consistently do it the same way, it will still work. So we're always going to have the red pyramid over the blue pyramid, no matter what we're looking at in the problem. That's the scale factor for the line segments. What about for the volume? Remember, you have to cube it. So that's 1/27. So that number, the cube of the scale factor, 1/27, will be equal to the ratio of the two volumes. The volume of cone B, the red one, is on top, 18 pi, and the volume of cone A is in the denominator. So all you have to do is cross multiply, and V will be whatever we get when we multiply 27 times 18 pi. So here it is, 486 pi cubic inches. Again, we're leaving it with a pi in the answer so that it will be an exact answer. Okay, we have two similar cones that have volumes 8 pi and 64 pi. Let's find the ratio of their radii, so we're going in a different direction. Well, let's see what the ratio of the volumes are to begin with. We know it's 8 pi compared to 64 pi, which is equal to 8/64, or just 1/8. That's the ratio of the volumes. How does that compare to the ratio of the radii? Well, remember, that needs to be the cube of the ratio of the radii. So in order to find the ratio of the radii, we have to take the cube root of both of those numbers. So the ratio of the radii is going to be 1/2. 2 is the cube root of 8. Obviously, 1 is the cube root of 1. So that's the ratio of the radii. Now we have a solid that is a composite solid, meaning that two shapes were put together in order to form one shape. This one has a cone on the top and a cone pointing down on the bottom. They both have the same radius of 3 yards. The cone on top has a height of 4 yards and the cone on the bottom has a height of 8 yards. So we're going to have to find two volumes and then add them together. Here we go. The volume of the first one is going to be 1/3 times r squared is 9 for both of these, but then times the height 4, so we get a total of 12 pi for the volume of the cone on the top. In the second cone, the cone on the bottom, we have the same radius, so we still have 9, but our height is 8, so that one will have the volume of 24 pi. So all we need to do now is add them together, and we get 36 pi cubic yards. Here is another composite solid, only this time we have two different types of shapes. On top, we have a cone with a radius of 2 inches and a height of 4 inches, and on the bottom we have a cylinder that has a radius of 2 inches and a height of 5 inches. So let's figure out the volume of each part of this solid, and then we will add them together to get the total volume of the solid. So we will begin with the cylinder, okay? Remember, the cylinder is going to be pi r squared h. So r is 2, so 2 squared is 4, times the pi times the height of 5, and we get 20 pi for the volume of the cylinder. Then we're going to do the volume of the cone. 1/3 the base area, same base area, times the height, which is 4. So what do we get for the volume of the cone on top? We get 16 pi over 3. So what we need to do now is combine those two volumes to give us the volume of the composite solid. So it's going to be 20 pi plus 16 pi over 3. And finding a common denominator, 60 pi over 3 plus 16 pi over 3 will give you a total of 76 pi over 3 cubic inches. Again, an exact answer. So thank you for joining me today, and I hope you understood the lesson. Let us know if you have any questions. Bye-bye.